Hello everyone. So today we will learn about the function generator, that is use of function generator using Proteus. So here we will first of all open the Proteus file over here so that you will know that is how the Proteus can be used from start. So Proteus is a simulation tool in electronics engineering where you can simulate the different electronic circuits or analyze the different electronic circuits. So instead of building the circuits on real time on breadboard, one can simulate or get the virtual analysis of any circuit using such kind of simulation tool. So we will first of all create the new project in the Proteus. So here you have to go for a new project. So inside this you need to provide the name for your project. So suppose name for my project I have given is ABC, and then you have to select the location. So here by default you will be going to get this path. Otherwise if you want to change you can browse for different path also. Then you have to press next. Then it is going to give you message like if you want to create schematic with default. So yes, we want to create default schematic for Proteus. Then we don't want PCB layout, so it is going to be highlighted. So next, so keep everything by default and you need to just create a schematic. So finish. So after clicking finish you will be going to get this kind of Proteus window. Okay, this kind of Proteus window. So accordingly, now here this is nothing but in brief I will just explain you the total scenario in Proteus. So this is nothing but your working sheet. This square indicates your working sheet. Here you need to place the different components or build the circuit here, and you are going to be analyzed. Okay, the circuit is going to be analyzed. Okay, then here this is nothing but one of the important term, that is nothing but component mode. Using component mode you can pick the devices. So you have to press pick. So Proteus includes almost, that is libraries of almost every devices in electronic circuits. So here you need to just search for that keyword. So if you want to use so today we will first of all see about the use of the oscilloscope or function generator in a Proteus. So we will type so you need to know that is different if you want to have different components in Proteus, then if you want to have resistor then you have to just type res. The Proteus is going to get you different components over here. So you have to select this resistor. So this we will see in the next part of this video. So first of all we will go into that is use of function generator in Proteus. So here in this palette you will be going to get the, that is different tools. So for that you have to select here the tool called as a instruments. So within the instrument you can have oscilloscope. So you have seen the oscilloscope in your lab, which is nothing but real time oscilloscope. So here it is a virtual oscilloscope. So it's going to give you the visualization of waveform virtually. Okay, all of you are getting the meaning of virtually. So virtually is nothing but without, that is without real time, means instead of mounting the circuits on your breadboard and then go for checking and analysis of circuit, first of all such simulation tools are used to carry out the analysis on virtual mode, and then laterwards you are going to build that circuit and get the analysis, get the results. Okay, so here this is nothing but oscilloscope. So for this if you want to create use that is different waveform generator, or if you want to create function generator, then you here you will be going to get different parts of that, that is oscilloscope. Here also you will be going to get signal generator. So we will going to take signal generator over here. So again zoom in zoom out options are available. So now here if you see that your components are out of screen, so how to adjust that? So on the left hand side you will be going to get adjustment for this kind of stuff. Okay, so here you need to fix that green square green rectangle in accordance with your analysis. Okay, so here this function generator can able to generate different kinds of waveform. So here the different properties have been provided. Okay, so here one can select different properties and get the analysis. So here suppose if I want to just observe the square wave, sorry, just observe the sine wave, one can observe that. And here negative means nothing but you have to provide ground. So all these kinds of terminals are available over here: input, output, power, ground. Here you need to provide ground, so I am going to select ground. Okay, so accordingly here this is nothing but here at this point you have to run your simulation. So run means your simulation is now running mode. So once you have been in running mode, this is nothing but the thing that is going to happen. That is nothing but the oscilloscope is going to be shown over here. And here we have applied sine wave to channel A of your oscilloscope. So here channel A is nothing but this. So by using this one can have, and that is sine wave produced. Okay, getting the points. Now using this one can have, that is adjustment of the time period. So it's just like your regular oscilloscope that you are going to use in lab, but in virtual mode we have created a sine wave. So we have created sine wave with, that is, here is nothing but the basically the sine wave. The amplitude of sine wave is going to be, this is nothing but your knob, and this is nothing but the, you can adjust the time period also by using this. Now you might be wondering about what is this, that is, this is nothing but your channel B, channel C, channel D. So in Proteus can have, that is, four channels, four channel oscilloscope. So accordingly here you can apply at a time four such waves and you can analyze those. Okay, so right now here for channel B, C and D the waves have been not applied, so you are going to get that as a just a straight line, but we have applied a sine wave here, so you are going to get that over here. Okay, all of you are getting the things. Okay, now let us change this source. So instead of having this function generator, if you take the different source of input, so different source here is in the sense I'm going to create, here you will be going to get generator mode. In the generator mode, suppose I want to create again sine wave here, sine wave. Okay, then if you double click over here, here you can adjust the different, you can generate sine wave with different values. So suppose let us say amplitude will be 1, frequency will be 1, let us keep that by default, or amplitude will be 5, frequency will be, let us take 500 hertz. So you can generate any waves. Okay, suppose if I want to generate pulse over here, then I can generate and give it to channel B of oscilloscope. Here also you can change the settings or keep by default. Now once I run this simulation here at this window, I am going to get this. So now here we have provided for channel A and B, we have provided. So it's going to be, actually we need to adjust the amplitudes because amplitudes are higher. So channel B, one can make of channel, we have provided to channel A and channel B. So one can make of for channel C, one can make of for channel D. So immediately you will be going to get the lines will be off, and only the lines available will be channel A and channel B. So by adjusting this again one can have the this. Okay. So right now the frequency of this pulse is different than your sine wave. So it's not going to be actually simultaneously, you cannot view that. Okay, all of you are getting. So again if you want to stop the simulation, you need to stop it over here. Okay, so in this way one can generate different uh, types of waveforms using the frequency generator. One can observe that over here. So in the similar manner one can create the, that is observe the frequency response, that is nothing but spectrum analysis. So spectrum analysis is nothing but observing the frequencies, or how to observe the frequency response of a particular circuit in a given for a given circuit. Then again if you want to if you want to mm, study that, then let us build one circuit. So one of the circuit will be our RC filter. So here one can have the resistor. So if I provide RES, I am going to get these kinds of similar matches, but I want generic device, so I am going to select that. So here you will find I have to put here OK. So I have put it resistor over here. I want capacitor, so I am going to if you provide cap as a search, you will be going to get this. I want generic capacitor. I have selected this now. Now OK with it. So let us take capacitor over here. If you want to rotate that, then again after right clicking you will be going to get this, and then just by left clicking you can join those components. Okay, now here if I want to provide ground, again here I need to go into terminals in ground. Here I have to ground this C1. For R1 again I want to apply the input, so I want to apply the input with a sine wave because it's RC filter. So again here it's a sine, so sine, here I am going to provide that. Now you can change the values over here. Suppose if I want to change that to, let us consider 5, frequency will be, let us consider 500, like that. Okay, so I want to measure response or spectrum analysis at this point. So you need to analyze, take probe, so voltage probe. I'm going to insert here voltage probe. Okay, now how to view the frequency response. So here in this graphs you will be going to get frequency. So you need to select that and you need to put it over here, frequency. Okay, so I want frequency at this point, or I want to analyze this. So drag this over here and then press space. You will be going to get the response. So here if you run this you can able to analyze the response now. Okay, over here. So in this way one can have the analysis of frequency response also. Okay, so again the graph is not working. Why? Because here inside this you need to give some, here reference is none, but we want to provide reference as R11 because we are going to provide input from R11. So you need to select that, then only it is going to run. So here at this point one can observe the frequency response also. Okay, so in this way, by making use of such kind of devices one can make the analysis in Proteus. Okay, thank you.